I would like to invite the first presenter for this session. I would like to invite Ms. Rena Ohara from Nihon University with the paper entitled Analyzing Structural Loss of Sustainable Distillation Process by Material Flow Cost Accounting. Okay, Ms. Rena Ohara, you may start your presentation.
Yes. Okay. Thank you for introduction. Today's our paper title is Analyzing Structural Loss of Sustainable Distillation Process by Material Flow Cost Accounting. Contents of this presentation consist of 5 parts. Keywords are MFCA, Environment Accounting, Distillation Process, Production Management. Section 1 is Introduction. Nowadays, the use of fossil fuel is growing rapidly, and forests are widely lost due to fires and lodging. It means massive CO2 emissions and a decline in CO2 absorption capacity. So, it drives to the situation that people should recognize global warming and world issues. Various international conferences have been held around the world to address global warming, and several international goals have been set. Here are some of them. One of the international conferences is COP-FCCC. This is Conference of the Parties to Global Warming Prevention Treaty. Next, Paris Agreement is a dating framework for global warming, and Sustainable Development Goals is 50 years environmental goals. Next, I focus Japanese industry. The chemical industry using large plant is expected to contribute the problem. In particular, the distillation process is a method of manufacturing essential product and consumes as much as 40% of the energy of all production process. This technique is old one that established in the early 20th century. Companies request that the quality of the distillation process is improved to meet customer requirements while keeping costs down. But there is not energy perspective about energy consumption and loss. This study focuses on this point. MFCA used to distillation process. MFCA is environment accounting method, including energy perspective. Also, this study aims at a simulation of performance improvement of distillation process in the collaborative chemical company by adapting MFCA. For this object, we will proceed with research with these purposes. First purpose is deepening the understanding of a distillation process and clarifying the structure. Next is that classifying raw materials, product, and waste in the clarified structure into positive product and negative product using by MFCA. After that, specifying the operation to reduce the negative product and setting the simulation condition for the evaluation of the performance improvement. Finally, simulating using the set conditions and quantify what kind of effect can be expected by improving the performance of the operations. Section 2 is Material Flow Cost Accounting. MFCA is one of the methods in environment accounting. This method focusing the loss of resources and energy in the manufacturing process and cost evaluation of material cost, processing cost, and the depreciation cost invested in those. Figure 1 shows calculation target of MFCA. Input focuses raw material cost and processing cost and depreciation cost. These are divided into waste and product throughout the manufacturing process. This makes it possible to visualization of loss. Cost reduction issues to be analyzed and examined by this method lead to resource and energy saving and aiming to improve production efficiency through environmental protection and cost reduction. Section 3 is research procedure. These are research steps. These steps were carried out with following plan. 8 study sessions were held in step 1 with company members and lab members. In this step, we conduct survey of distillation structure. Step 2 and Step 3 conduct only lab members. In Step 2, we setting simulation condition for each type of structure. In Step 3, we implement simulation and the result could be represented in a graph. In Step 4, one session was held with company members and lab members. In this step, we found 6 findings and the direction of improvement of finding 2. Section 4 is research results. This step is investigated distillation structure, and the structure of 3 types of distillation processes are expressed by equation 1 to 9. Figure 3 shows the distillation processes structure. Type 1 shows distillation process with only reflux. This input mixture and reflux, and output reflux and product. Type 2 shows distillation with reflux and one type of disposal. This input mixture and reflux, and output product and waste and reflux. Type 3 shows distillation with reflux and 2 types of disposal. This input mixture and reflux, and output reflux and product and 2 waste. And then we could identify which is negative product. On type 1 is reflux, type 2 is reflux and waste, type 3 is reflux and 2 kind of waste. Step 2 is simulation conditions for distillation process redesign. For each type of distillation structure arranged in step 1, the simulation condition of 11 patterns in table 1 are set in order to examine how changing the operating conditions affect the negative product. This simulation conduct under steady state plus 0, 1, 3, 5, 10% of operating condition in each pattern. Step 3 is changing in the distillation process. These graphs are the result of each simulation. Figure 3 and 4 show the result of simulation under type 1 conditions, and figure 5 and 6 shows the result of simulation under type 2 conditions. Figure 3 and 5 shows change in negative product ratio, and figure 4 and 6 show the rate of change in negative product ratio. Figure 7 to 9 shows the result of simulation under type 3 condition. Each graph shows change in negative product ratio. Step 4 is approaches for environmental friendly distillation process. Table 2 shows a summary of simulation result. It found from Table 2 that there is a proportional relationship between the degree of the change in operating condition and the negative product volume change. However, the relationship in the finding 2 is discussion in next slide. Figure 10 and 11 show the contents of Figure 4 by dividing them into 2 types of trend. Figure 10 shows the 3 lines with the low reflux. These are case of product amount is higher than the reflux amount. Gray line correspond to type 1 to 3, and black and light blue line correspond to type 1 to 4 and type 1 to 5. It is said the larger the amount of reflux is, the smaller the rate of change of the negative product amount is, when the reflux amount is larger than that of the product. It is also the same result to other simulation results depending on the negative product volume. Figure 11 shows the 3 lines with high reflux. These are case of product amount is lower than that reflux amount. Orange and blue line correspond to type 1 to 2 and type 1 to 1. This trend to be different from the previous case. The smaller the amount of reflux is, the larger the rate of the change of the negative product amount is, when the reflux amount is larger than that of the product. This Factor is due to the negative product ratio. Finally, section 5 is concluding remarks. First, discussion is the relationship between identified performance improvement and the negative product were obtained by the quantified result. From this, the direction of improvement in the relationship between the amount of reflux and the amount of product could be clarified. When the amount of reflux is smaller than the amount of the product, it is effective to change of the operating structure themselves. On the other hand, when the amount of reflux is larger than the amount of the product, it is effective to change of the reflux conditions. Finally, these points are further issues. First is the practical proposal of how to use simulation result. This paper ends when the simulation is performed and the results are considered. Consideration of what will lead to a step on technological improvement for distillation should study how to use the result of simulation conducted this time. Second is the implementation of simulation that combine reflux, product, and waste. This paper performed a simulation that divided into 3 types. It is also possible to change only one of the operating conditions, but it is necessary to consider the simulation due to the change of the 2 or more conditions. These are references. Thank you for your attention. Thank you.
Okay. Thank you for your presentation, Ms. Rena Ohara. And I would like to invite the participant if there is any question regarding the presentation of Ms. Rena Ohara. Please, you may type your question in the chat room. Okay, first of all, thank you, Ms. Rena Ohara, for your presentation. I think it's a very interesting research, and I think I just want to know and curious about one thing about the distillation process in here. If there's any improvement that can be conducted regarding the process itself, what it should be looks like. About the process. Yeah, about the process itself. Yeah, about the distillation process itself. If from your future issue that can be conducted from your research in here, you talk about some improvement regarding the distillation process, right? If I'm not mistaken. Or maybe can you explain a little bit more regarding your future research that might be conducted from your research in here?
Yes, and further issues, second further issues, I said implementation of simulation, combined reflex, product, and waste. And I want to continue simulation with combined the simulation conditions.
Okay. So you would like to test the simulation result with different conditions. Is that the point is maybe one of the future research that can be conducted from your research now is you might test the you may simulate into different kind of conditions, right?
Yes.
Yes. Okay. Any question from the participants in here? If you have no further question, we thank you, Ms. Rena Ohara.